we're now ready to get into some really useful skills when working with linear equations. We already know what slope-intercept form is. We did that in the last chapter. We reviewed that in the last unit. So now in 5.4, the I can statement is I can change linear equations to slope-intercept form. So slope-intercept form. Now, if we say slope-intercept form, we should keep in mind what we're talking about is the slope of the line and the y-intercept. Some people lose sight of that fact that we're really talking about the y-intercept there. So keep that in mind. And we're going to start off with a bit of an interesting review here and maybe some ideas that you haven't thought of before. So in the first part of the warm-up it says use inverse operations to isolate y. So remember, when we say isolate, it means get the y by itself. And then I've got a couple extra questions right here that are kind of self-explanatory that we'll explore in just a second. So let's take a look at this one right here. We want to solve this for y. We want to isolate the y. So the first thing we're going to do is notice that this is the variable term right here. So we're going to get rid of the 2 by subtracting 2 from both sides. So we're going to go ahead and do that. Those, of course, cancel each other out. They make a 0. Those are additive inverses. So we get 3y on this side, and then on the other side we get a 7. We're going to finish off getting the y by itself, isolating that by getting rid of this multiplication by 3. Remember, that's implied multiplication there. So we're going to divide both sides by 3. So we end up with y equals 7/3. So I'm going to go ahead and circle that. Now, the minute we take a look at this one, this looks absolutely bizarre. But remember, we talked about this before. We said the reason that we use letters in math is we use those for variables, and letters are just a very convenient choice of symbols. Everybody knows lots of different symbols, but one symbol that everybody's familiar with is we know the alphabet really well. So if we say draw a Y or an X or a Q or a P, everybody knows what we're talking about. These would be kind of a pain in the butt to work with. You'll notice that we've got a Y right here, and we're still going to isolate that Y. But now the coefficient, if you want to think of it that way, is a circle with a cross in it. The number right here, or the constant if you will, we've added a triangle, and then on the other side we have a square with a dot inside. Okay, so weird way to write this down, but we can still work with this. We want to isolate the y. We want to get the y by itself using inverse operations. So what we're going to do is we're going to take this term right here, just like we did before, and we're going to say, look, those are stuck together with multiplication, so I'm going to leave those alone. We're going to get rid of that triangle. So what we're going to do is we're going to subtract the triangle from both sides. Now, this side looks pretty ugly. We'll deal with that in just a second. But this side over here, triangle minus triangle, those are going to cancel each other out just like those did. So we end up with a circle with a cross in it times y on this side. And then I've got a square with a dot in it minus a triangle. Well, let's see. I have no idea what those are. They're not really like terms if you wanted to think about them that way. So what we're going to do is we're going to write the square with a dot in it minus the triangle. We're going to say, look, I know I'm supposed to subtract these, but I don't know what they are, so I can't really subtract them. And then the last thing we need to do is we need to get the y by itself, so we need to get rid of multiplying by that circle with a cross in it. So we're going to divide this side by a circle with a cross in it, and this side by a circle with a cross in it. We're going to cross those off, and we're going to get y is equal to, so we get this ugly mess. So we get a square with a dot in it minus a triangle, and we're going to take that whole thing, notice that fraction bar covers the whole thing, and then we're going to divide by that circle with a cross in it. This right here would be what we get when we move that around. It's just like solving this equation over here on A, except for this time we don't really have any numbers. So here's the value of doing something like this. When we were doing A, we knew what the numbers were, and we could say, okay, the answer is 7 divided by 3. When we're doing problem number B, when we go through this process, what we're saying is, look, I don't know what these symbols represent, but if you told me what the square with the dot in it is, what number it is, I'd put that right here, and then I'd subtract whatever the triangle equals, and then I'd take that whole answer and I'd divide it by whatever the circle with a cross through it is. Okay, so I know it seems kind of weird, but it is a valuable skill to have. Next, on these last two in the warm-up, we're going to take a look at some seldom used properties of fractions. So I want to take a look at this one. Now notice that these are all numbers except for this right here, so we can deal with this a little bit easier. So we've got 4 plus 10 divided by 2. The question is, does that equal 4 divided by 2 plus 10 divided by 2? Well, if we went ahead and added those together and evaluated like we would a normal expression using the order of operations, we'd get 14 over 2, and so on this side we'd get a 7. So we know what number that equals. And if you'll notice, what happened here is we basically took each one of these terms, the 4 and the 10, and we did 4 divided by 2 separate from 10 divided by 2. So 4 divided by 2 is 2, plus 10 divided by 2 is 5, and if you add those together, you get 7. So yes, that actually works to break those apart that way, and that actually is a property of fractions, and we're going to be using that and talking about that in just a second. And then this next one right here is, it says, is x over 2 the same as 1/2 of x? Well, let's think in terms of the way we could describe this. This is x divided by 2. So if you take something and divide it by 2, is that the same as taking something and multiplying it by 1/2, taking half of that? Well, the answer to that is yes, and there are a couple different things we could do. We could pick a number and kind of verify this. So let's pick the number 18. So if I did 18 divided by 2, is that the same as 1/2 of 18? Well, 18 divided by 2 is 9, and half of 18 is 9, so that would work. And we can also verify it one more way. What if I were to put this over 1? Remember, we mentioned earlier this year, if there's a fraction in the problem, you might as well think of everything as a fraction. So if I do 1/2 times x over 1, if I multiply the things on the top together, I get an x, and if I multiply the things on the bottom together, I get a 2. So I've kind of gone around in a big circle. I've gone from x over 2, writing that as a 1/2, kind of pulling the coefficient out in front, if you want to think of it that way, because that really has a 1 there. So we kind of pull that out front, multiply it by x, and then we just did the opposite. We multiplied these together. So instead of having a multiplication problem, I've just got this x divided by 2. Okay, so keep those in mind. We're going to use those again in just a minute. Now, if we've got a linear equation in slope-intercept form, everybody knows how to graph that. Y equals mx plus b. We're very familiar with that by now. But what do we do if it doesn't come in that format? Well, if you take a look at slope-intercept form, it always looks like this. We've said this over and over and over again. Y equals mx plus b. Notice that the y is always, we're going to use that fancy word, it's always isolated. In other words, it's always by itself. And we typically put it on the left-hand side of the equation. So getting y by itself is just one of the keys to putting a linear equation in slope-intercept form. There are some other things that we need to be pretty good at using, and they are the seldom used properties of fractions. So write the word fractions right here, and we're going to take a look at these a little bit more in depth. These are really, really valuable skills. So the first one is, if a fraction has more than one term in the numerator, in other words, if it has more than one term on the top, then we can put each term over the denominator. So go ahead and write denominator here. And when we say denominator, we're talking about the bottom. So I'll go ahead and put that up here. We'll just remind everybody we're talking about the bottom. So if a fraction has more than one term in the numerator, in other words in the top, we can put each term over the denominator, so each term over the denominator, the bottom, separately, and then reduce. Okay, so as an example on this problem right here, a little bit more sophisticated than the one that we did up here, we can actually take this and break it up this way. We're going to do 6x over 3. So we're going to take the first term, put it over the denominator. Notice there's the plus, and then we're going to do 15 over 3. And the value of doing that is now we've got something that easily reduces here and something that easily reduces here. So here's what we end up with. That's going to be a 2, and that's going to be a 5. So we end up with a 2x plus a 5. Now, if you had to work with this expression or this expression, I think everybody would agree that the 2x plus 5 is way better than the 6x plus 15 all over 3. So again, same type of example. Let's write this down as 8x on the top with a 4 on the bottom. Let's write this as a 7 on the top and a 4 on the bottom. And if we can reduce it, we're going to go ahead and reduce. These will cross cancel, so this is going to end up being another 2x. And then on this side, we don't have anything to cross cancel there. And again, we're not going to write this as a decimal or anything. We're just going to write that as 7/4. We're going to keep that. We might keep in mind that if we had to graph this, that would be 1 3/4. Not a very fun point to graph on the xy plane, but we could do that. And the second one, if a fraction has more than one factor in the numerator, so notice that this one is about more than one term, so we've got a plus and minus separating it. This is about more than one factor, so we've got a multiplication problem in the numerator. Then what we can do is we can write part of the fraction as a coefficient. So write the word coefficient. we should know that word really well, of the remaining factor of the numerator. So here's what this means. That's really wordy, but here's what it comes down to, just like we were looking at in the warm-up. If we have 6x over 2, then what we can do is we can slide the numbers out in front and just have those as the coefficient on x. So instead of mixing these together in the numerator, what we do is we say, hey, let's get the numbers all out front and let's deal with those separately. So this would be a 6 on the top and a 2 on the bottom. And then we can cross cancel. Of course, this is going to end up being a 3x. And we'd be finished right here. Now, again, everybody I think would agree that 6x over 2 is not quite as nice as just writing plain old 3x. Same thing if we had something like this. If we've got 3 times x on the top, notice those are the two factors, and a 5 on the bottom, then we can write the numbers out front, pull that 3/5 out as a coefficient, and then the x on the end. And this doesn't reduce or anything, so that right there is the answer. Now, the nice thing about this is it's easy to look at this and identify what the coefficient is. And there are lots of times where we're just interested in the coefficient. We're not interested in mixing the x's in there or anything like that. So really good tool there. So please make sure you keep those in mind and refer to those, because what we're going to be working on today is just writing each equation in slope-intercept form. So that means we're going to solve for y, and then we're going to simplify the result. So every single one of these has to look like this. It's got to be y equals a number times x plus or minus a number on the end. And of course, this is the slope and that's the y-intercept. So let's go ahead and take a look at this. I've got 5 problems to look at. And here's the first one. Notice here's the y right there. So we want to start getting that by itself. So the first thing we're going to do is we're going to move that 10x to the other side. So in order to do that, we're going to add 10x here and add 10x here. Now, I'd like you to ignore this other side for just a second. Let's focus on what happens over here. It's just like we're used to. These are additive inverses. They cancel each other out. So on this side, we have a 5y, and on this side, we have a negative 40 plus 10x. Now, if you remember some of the rules for combining like terms, those are not like terms. They don't both have the same variable. They're both not constants. And we normally write them in what we call descending order. So we write the variable terms first, and then we write the constant at the end. So here's what we're going to do. We're going to write this as 10x minus 40. Now, there are a lot of people that say, hey, could I just write it backwards? Could I write negative 40 and then plus 10x? The answer to that is yes, you could, but you'll notice that these are in the wrong order for slope-intercept form. We always have the x term with its coefficient at the beginning, and then we've got the constant at the end. So you could do this right here, but it generally would be a bad idea. It's just going to make things more complicated than it has to be, and it also doesn't follow our general rules for simplifying expressions. So then the next thing we're going to do is we just need to get rid of the 5 in front of the y. Notice that's implied multiplication, so we're going to divide both sides by 5. I'm dividing this entire side by 5 and that entire side by 5. And notice what we have here. We now have a y. Then we've got a little bit more work to do on the other side. So although we have the y solved for on this side, over here we've got a 10x minus 40 on the top and a 5 on the bottom. So this is where those skills up here come in handy, these nice properties of fractions. So we're going to write this as 10x over 5 minus 40 over 5, and we're going to reduce each one of those separately. So I'm going to write y equals, this would be 10 over 5 with the x there, and then this would be minus 8. So the best way to write this would be, after we apply both of those properties of fractions, break it into 2 separate pieces for each one of the terms in the numerator, and then pull that 10 over 5 out front, we're going to end up with this. 10 divided by 5 is 2 minus 8. And that right there is the answer. Now, I did all of the work on that one. I showed every single bit of it. I am going to speed this up just a little bit on several of these. So I'm going to go ahead and change colors on this one so we can keep these straight. Here's the y term right there. So here's what I want to do. I want to keep this over here, and I want to get rid of the 4x from both sides. So I'm going to subtract 4x, and I'm going to subtract 6. Get rid of both of those at the same time. Those go away. And then I have a 2y over here, and I have a negative 4x minus 6. Then we're going to divide everything by 2. So I'm going to divide both sides by 2, and those are going to cancel. So I get y equals, now if you can do this all at once, that would be great. I showed every single step broken out on part A over here. But let's see if we can think of it this way. This is going to be negative 4 divided by 2 with an x on it when we break it into its 2 pieces. So this is going to be negative 2x. And then this is going to be negative 6 divided by 2, so that's going to be a negative 3, and that's our answer right there. Okay? So I want you to keep that in mind And then I'm going to come back up here and I want to show you something. Um, we had to move two terms over to this other side. So if you're thinking we might be able to take a little bit of a shortcut, and that would be this. What if we moved the 2y over here? So I'm going to do that, and I'm going to change colors here. I'm going to do this in green. So I'm going to, whoops, that's going to be a subtract 2y over here and subtract 2y over here. So this is going to be a 4x plus 6 equals 2y. Now, some people, it kind of bothers them if we have the y over there. So what we could do is we could just do a quick pancake flip. I'm going to flip the two sides. So this would be 2y on this side, and then I'd have 4x. Ooh, that's going to be a minus 2. Forgot about that. 4x plus 6. And then we're going to divide both sides by the negative 2. And again, it's just the negative 2. We like the y. So we're going to have y equals 4 divided by negative 2 is negative 2. And there's the x on there because we were dividing the two of those. And then we've got the 6 over negative 2, so that's going to be negative 3. Okay. Now, you certainly don't need to do it with two different methods. We get the same answer either way. A lot of people kind of like this one. Some people like doing a little bit less work and maybe flipping sides at the same time and stuff like that. But either way is totally okay. So let me take a look at this next one. You'll notice on this one, take a look at this, the y is already on this side. Okay, so the y term is already on one side by itself. The only thing we need to do is get rid of the 3. So we're going to divide both sides by 3. That's going to cancel off, so that will leave us with a y over here. I am going to write this one out just to be clear. This is going to be a 5x over 3 minus a 12 over 3. So this is going to be a 5/3 x minus 4 equals y. And if we're really quick with this, we might be able to flip the sides at some point before now, but when we're done, we always want to have the y on the left-hand side. So this is going to be 5/3 x minus 4. So that one, really there was one step other than flipping the two sides of those and then making sure that we simplify that correctly. Okay, let's take a look at this next one here. This is D. We want y on one side all by itself. So here's the y term. Now, we could move the x term to the other side, but we do that by subtracting. We tend to make more mistakes with negatives and with subtracting than we do otherwise. And we'd have a negative right here. And it also would leave the y on the right side and put the x over there. So we're going to do something that maybe is a little bit more efficient. And again, there are lots of different ways to do these. I'm going to go ahead and add 4y to this side. And I'm going to add 4y to this side. So, whoops, those are going to cancel each other out. That's going to leave an x over here. 0 plus 4y. 4y plus 0 is just 4y. And then we've got the y term over here and the x term over there. So that's good. We've got one step left to isolating that y. We're going to divide both sides by 4. So I'm going to cross that off. We're going to get y equals. Then we normally write this as a fractional coefficient. So we're going to pull the numbers out front. But then the question is, well, what's the number right here? Well, remember, that's understood to be a 1. So this is 1/4 x. There's no constant at the end, so the y-intercept on this one would be 0. Okay, so being able to manipulate these algebraic expressions, using our skills for solving equations to just isolate one of the variables, very, very valuable technique. But again, take a look here. We see that this is y equals 1/4 x. That right there is the slope. The slope would be 1/4, and the y-intercept on this particular one would be 0. Okay, let's take a look at this one. Again, you'll notice that everything's on the same side. So if you wanted to move the y to the other side, you could. If you want to move both the x and the negative 11, that's totally okay. I'm going to go ahead and do that on this one just to kind of stick with things on the left-hand side. So I'm going to subtract x, and I'm going to add 11 to this side. I'm going to subtract x and add 11 to this side. Those will make a 0, and those will make a 0. So I have a negative 2y. And then I've got, notice that I've written these in the right order. I've written them in descending order. Variable first, and then the constant at the end. And then we're going to divide both sides by negative 2. Okay? Now, when you get to this point, if you're quick, then you can do this. We know we're going to be breaking this into two pieces anyway, so let's divide each one of the terms by 2. All the terms on this side by negative 2, and all the terms on this side by negative 2. So those are going to cancel. We're going to have a y here. Negative divided by a negative would be a positive, and the number here would be a 1, so this is going to be a 1/2 x. Positive divided by a negative is a negative, and then again this is going to be 11 halves. So we're not going to change that to a decimal. We're just going to kind of keep track of the fact that the exact number is negative 11 halves. The original problem wasn't written with fractions, so we're not going to write our answer with a fraction. Okay, today's assignment is basically just moving things around so that they're in slope-intercept form. So again, our goal is to make them look like this. Y equals mx plus b. That's what we want. We just want to know what this number is and what this number is. Okay? Good luck on the assignment.